Hello everyone, see you again with me Aston on Zona Otomasi, a channel that reviews in automation technology, IoT and Industry 4.0. This time I will discuss about the Building Automation System or BAS. Okay, let's go. Okay, BAS or Building Automation System is a category in smart building. So smart building have a four category. The first is Building Automation System, air quality monitoring, security and access control, and AI and IoT. Okay, let's straight to the Building Automation System, or BMS, sometimes Building Management System. Okay, Building Automation System is a system that controls the HVAC, or heating, ventilating, and air conditioning, and chiller control, lighting control, electrical and energy monitoring, genset monitoring, and fire alarm monitoring. Well, according to the Global Design Standard, or in BMS, Building Automation System or Building Management System is a layered and networked architecture of controllers and devices with functionality for continuous operation and monitoring of building mechanical and electrical systems. So, based on this picture, we can see that the purpose of building automation system is for boost energy performance and comfort of the building. We can see that on the basement, we can see also there's a infrastructure for supplying the energy like electricity, gas, water, and something like that to the upper of the building, like lift monitoring, and then status monitoring of equipment like line monitoring, and another is occupancy rate monitoring. Another crucial system is also keep track of the temperature and humidity. And another is for energy monitoring like electricity and also the ventilation system. Okay, the main point for building automation is for energy performance and comfort. This is the system architecture for BMS or BAS. From the lower, we can see that there are a sensor and actuator level. This is for sensing the physical parameter. In the upper layer, we can see the field controller level. This field control level is used for data acquisition and converter. You can see the VAV controller, VFD, and also chiller controller and backnet controller. There is also a DDC, or sometimes we can see the PLC or RTU in this point. So another upper level, we can see the master control interface. It's something like what's like a main controller. So main controller is for data processing and control system. They can control all of this control level, field control level, and then communicate to the network. So management level, we can see for monitoring and also for controlling and the supervisory level. In this level, we can also set the analytic and alerting and also device management. So it's very crucial to know this architecture before we going to deep dive on the building automation system. When we talk regarding the control system, we have to know for each protocol or each communication protocol. Building automation system have several protocols, but the first is Modbus. Modbus consists of Modbus RTU, Modbus TCP, Modbus ASCII, and is usually used in PLC, DDC, SCADA, BMS, power meter, genset, and also fire alarm. Another one, we can see that BACnet is a building automation control network. This BACnet system uses the Ethernet or sometimes BACnet over IP or over serial, and also MSTP. The new one, we can see that BACnet SCR Secure Connect. BACnet usually use a DDC controller or BMS controller, HVAC, air handling unit, or lighting. Another one, you can also see that LoanWorks. LoanWorks is a communication protocol that use Ethernet, power lines, twisted pair, or sometimes peer-to-peer network. This protocol sometimes usually used in medical, home, building, or utility monitoring. Another one we can see the KNX protocol. This protocol use a twisted pair cable, also sometimes used for IP, radio frequency, and also power line. The KNX protocol usually used in lighting control, blind and shutter control, audio, video, and also display. It is much more like audio, video, and multimedia control. Another specific one is DALI. DALI is a digital addressable lighting interface. It is specific dedicated for digital lighting control. Okay, this is 5 major communication protocol in building automation system. Okay, we have a diagram or architecture for infrastructure control. This one, we can see that building management system is consists of DDC that use a BACnet protocol, and sometimes use a Modbus TCP protocol, and sometimes use Modbus RTU protocol, and also another one we can also use IP camera to integrate in the building automation system. Sometimes third-party facility management, something like elevator, two-way lighting, access control, and fire alarm system. So in this one, we can integrate into the Ethernet network for integration to the upper level, like a SCADA or building management software. And from this, we can also use redundancy software for redundant system. And this software also available for a mobile application, so the user can also monitor on their smartphone. Another example for building automation is energy monitoring. So energy monitoring in building, usually we use a power meter, digital power meter. So digital power meter usually use a Modbus TCP protocol or Modbus serial protocol that can be read or can be translated with a protocol converter like AKI for Advantage one. Something we use Modbus TCP. From this converter, we can directly connect to the RTU. This RTU is monitoring the power meter via a network of campus network, a ring protocol, a ring network. So you can use another display like touch screen SMI or maybe a computer monitor, something like that, for connecting the controller to the IP-based network. This is example for dashboard or BMS dashboard for electrical monitoring. So the red one is indicate that the electrical network is not connected to another, and the green one is indicated that the network is connected to another network. This is a dashboard for a genset. So when in a commercial building, usually the building management system use the redundancy genset is for a backup when the main genset is failed, so the second genset can back up on the operation. We can see that the monitoring from genset can be control status, engine status, overspeed, and frequency within limit. Sometimes we can monitor the electrical parameter on the genset like voltage, phase 1, phase 2, phase 3, and current, phase 1, phase 2, phase 3, also frequency, and also a power factor, something like an electrical parameter. Another one, we can see a BMS dashboard for air handling unit. So this one is the parameter for air handling unit, something like return temperature, return humidity, and also enthalpy. Another one is outside air with flow through this air handling unit. So we can see this heating. Heating status is off. Heating valve command is 0%, and coil differential pressure is 0.2 inch. And another one is in cooling, and also a freeze, supply fan, smoke detector, something like that. There's so many parameters that we can monitor on air handling unit. Okay, this is a very crucial one also. So in lighting control, we have a specific protocol for controllers, and this one is using a DALI, digital addressable lighting interface. This DALI protocol use a specific method. The first one is broadcast, DALI broadcast. DALI broadcast is a broadcast system to the another room, something like office one, open office, and meeting room. And then the daily addressing, we can see this. Each lamp has its address, something like 12, 9, 23, 61, and something like that. And also, this lamp is also interfacing with a peer sensor or infrared sensor. So when there is people in this room, so sensor detect the people, and then it can set the lamp on, and vice versa. When there is no people or no person in this room, the controller set the lamp to off. So it will reduce the energy used on the building. And then multi-master can be used between broadcast and addressing. This technology usually used in a Signify product. Okay, talking about energy efficiency, we can also talk with measurement. So measurement is fundamental to energy efficiency. The first step for energy efficiency is measuring. So we can measurement and data collection from build device, something like sensor and actuator. The second phase is integration, real-time data integration. The third phase is optimize. We can integrate automation and control system. The fourth phase is monitor. We maintain and evaluate the result with SMA dashboard, historian, and trending. The last one is a feedback. Users have to change the behavior of energy usage, so it can directly fit in the measuring. So the main objective of this is measuring. When measuring is good, so all of the processes have a good feedback for energy efficiency. Okay, this one is a air quality sensor integrated to the BMS. I I have a example for Honeywell. So Honeywell have a multi-purpose sensor, something like that. They call a IAQ sensor in wall and also in ducting. The sensor monitor temperature, humidity, carbon dioxide, TVOC, and particulate matter. From the sensor, it can also connect to the Modbus gateway. Gateway send the measurement to the DDC controller, and the DDC controller can be monitored in a BMS software. So, and there is also IAQ sensor on the ducting. It means when there is a dangerous particle detected with this sensor, the controller directly control the air handling unit to minimize the disease for this particulate matter. It can be used in a commercial building, a hospital, and also in the hotel, something like that. Okay, we talked about BMS. Now we can conclude on the benefit of building automation system. The first one, when we use building automation system, it can higher energy efficiency. So we can reduce the usage of energy like electricity and water and also gas for this building. The second one, we can lower operating and maintenance costs. Yes, of course, we can lower the operating and maintenance costs because we can reduce the personnel to the site. The personnel can monitor all of the building parameter with a smartphone or something like that, with a gadget or on the laptop. The third one, we can use building automation with result of better indoor air quality. The last one, building automation system can result a greater occupant comfort and productivity. So these four benefit is a sample of a building automation system. We can also take benefit from the building to the tenant for another added value. So this is our last slide. So enjoy the slide, enjoy the explanation. So you can share your comment below. You can share your experience regarding the smart building or building automation system. Okay, thank you for watching.